So thank you to be here today. Edo, I don't know if you want to introduce the general theme of our PhD course, and then I can introduce our guest today.
Okay, thank you so much. I would like to say thank you so much for our guest today. He's YUAN. He's a very close friend, not just for this university, our department, but also the China Room research team that we already cooperated in the past. We met the first time in a Shenzhen Biennale with a big installation, I remember. But what is important today, then I let Valentina to introduce the guest in the right way, to remind the very main objective of this course, that also to help a bit YUAN to address the question. This morning is a PhD seminar within the Position AI PhD course that would like to address some question around research and practice, how AI is changing some directions. That is, we are not having a course, let's say, for having new skills in AI, or that our students at the end of the course, they have new skills in maybe generating images or as a sort of technical course, but it's to address more on a methodological way. So how AI is changing the way we are doing research, and how, since practice and design practice many times is our say focus point of our researches, what is changing in the world of the architectural practice as well. So in this course, many times we talk about this politics of the archive, since AI is based and generated on data and databases. So the way new and some studios, selected studios, are shifting in another direction and thinking about data in a different way. If it was maybe an archive just to accumulate for a past, or maybe in the future using that past to rethink on what has been done in the history of a studio, so more on a historical and critical way, we are addressing how the archive is becoming part of the way is produced architecture within the process itself. So this means that for us is becoming more and more relevant how new practices are changing their production tools, and how this production tool changes is going to be changing in the way they also exchange between different studios. So the idea is also thinking how is going to be in the future. This database will be part maybe on another way to arrange practice, the way studios will exchange information or use the information they exchange to fastening some parts of a process that maybe has been, let's say, handcrafted for many years and maybe now are changing. Or what is resisting? That is the other part of the discussion. Something cannot be, can join this digital archive. Something needs to remain really handcrafted, written, not exchanged, maybe secret, maybe not delivered, let's say, disclosed to others. There is competition, patent. So this sphere of is part of the politics, as we said, because it's a selection on action that we are going to do or not to do. So YUAN, we wanted to invite Valentina to explain more in deep why, but especially because you had the chance in your lab, as we know, to have that crossing point between practice and research, first of all. That is exactly, I hope also many students will address you many questions about that, but also about what you are going maybe to disclose also, to explain tonight in the other lecture, because digital future is based on platform. So this idea of precisely the of politics, to be transparent, to be transversal, to be shared. So I think this YUAN is a very guest start for us to address some points, starting from his personal experience, but also from his research line and the perspective as a scholar. Thank you so much.
Thank you. Thank you, Edo. Yes, okay, yeah, sorry for the recording. Today we have a pleasure to have a lecture of Professor YUAN. He is a professor and associate dean at the College of Architecture and Urban Planning at Tongji University in Shanghai. He is an honorary fellow of the American Institute of Architects and an editor-in-chief of the Journal of Architecture Intelligence. His research spans performance-based architecture tectonic, the development of intelligent construction technologies, and the integration of intelligent equipment in architectural design. Professor YUAN, as Ada was mentioned before, he's able to translate the theoretical investigation into like a professor and a researcher, bridging speculative research and architectural practice, and also create a interesting platform that is the digital future that is the 15 years now at addiction and July of this year. So I think you have the opportunity to open a wide discussion about the use of new technology and architecture practice. So thank you to be here today. I just leave this.
Thank you, Valentina. Thank you, Professor Bruno and Professor Bocelli. I think it's a long-term friend from Shenzhen Biennale. Actually, it's before the COVID. Carlo Retti is you co-curate the Shenzhen Biennale. I'm in the group of yours. I still remember it's a very special memory before the COVID. So this year is a very special opportunity coming back to Venice Biennale. Still working with Carlo. I think and that's totally based on my background as introduction from Valentina. It's I'm a professor firstly and organize a different education event and also organize the research laboratory in Tongji. And so as well as I'm a practitioner, I also doing some like practice, the real buildings, which is booming over the past few years in China. So today I will starting from theoretical review. Share. Okay.
Sorry. Thank you. Yeah.
Can you see my screen? Online?嗯，刚才已经 share 了，为什么没有了？这下，就打开。
I think you have to log out and log in.
Okay, okay, I see. Okay.
Now just how to from Teams the phone directly. So just leave the leave Perfect. Okay. Nice.
Okay.
Everything for you. Okay.
Can this be smaller?
Yeah.
Okay. Yeah, I start from the topic today, AI Tectonics, which based on the Digital Future event, every year we have a special topic. Last year is co-agency, co-pilot, and coexistence. So I try to analyze this topic, AI Tectonics, to position in how AI to our architecture discipline. So what is the new humanism today? Like Gilbert Simondon mentioned, we should, on the one hand, extract humanity from the living matter. On the other hand, we should introduce technology into the culture. That's a very special moment to analyze this dynamic humanism based on the relationship between the nature, human, and the non-human. So it's a very special also topic related to the Venice Biennale this year. Carlo put forward also a rethinking on what is new humanism. And several years ago, I invited a philosopher whose name is Benjamin Bratton, coming to Shanghai, who put forward a very interesting topic on what is terraforming the urban planetary. So he mentioned the planet is redefined not by the national boundary, but goes to all the way goes to different rethinking ways by the internet and by the what is the computational lifestyle in the whole planet. So the planet was subdivided in different layers. The layers including the user, the interface, the address, the city, the cloud, and the earth. That is rethinking on the planet, how we rethinking on the resources, how we rethinking on the human life, and how to rethinking on the relationship between human and non-human, and also the networks of the international networks also redefine our edition and our influence and also our economic culture. This is last year Digital Futures event. We normally put forward topic and rethinking and quickly make discussions over the last 1 year on this special topic. So last year the topic is architecture as a planetary science, which is what is a planetary science is the scientific ways is introduced to the architecture design that is not just a humanization, a humanism research. It's not just about culture. It's not just about the heritage preservation. It's about what is the future, which is totally good based on the reorganization and restacking of the resources that we're thinking on the sustainability of the planet. So we mentioned the three keywords, the co-agency, co-pilot, and the coexistence. So this is last year, over 500 people participate, and we make a lot of discussions and more than 20 workshops totally in Shanghai. And this is the 15 years history of what is we mentioned Digital Futures. We attract the participants, more than 128 nationals, and also over 15,000 membership for Digital Futures. So also we define this special platform and collaborate with UIA. And in 2022, we make a proposal on the topic One Planet. And also we would like to critically rethinking the architecture culture, technical culture, which is based on the new sustainable thinking. So last year it goes back to these three keywords. What is the co-agency, co-pilot, and the coexistence? Actually, which based on what is the future we should define, what is the best future for the future for our planet. I think there are three kinds of diversity. The first is the biodiversity, is as much better as the ecosystem could be preserved, and the more biospheres could be redefined, not just man-made, we planting trees, we earning different kind of animals, but we should goes to the natural. So the nature is actually should based on kind of biodiversity. We make a research on Shanghai. 80% of Shanghai biosystem is actually man-made. It's not natural because it's the metropolitan, the urbanization process of Shanghai is actually destroy the system of the biosystem. So what is the future we're thinking about? Maybe the co-agency is not just about human being, the agent. The agent could be like animals, non-humans, and also could be intelligent agents, like the computational agents that can help us to redefine the behavior pattern of, for example, the birds and also the fish, and we can like tracing their behavior pattern based on different kind of intelligent agent. That is a kind of co-agent system. So the serving is not just for human being. We should reconsider our relationship with the nature. So that's a kind of a biosphere research. The second, I think, based on the co-agency, the human and non-human agent in the future, we're thinking on the instrument. So the technical sphere is important. The diversity of technical spheres is what we consider to the academic world. So the co-pilot, like the pilot sitting beside your car, help you to define where to go, maybe the mapping the cities and tell you maybe turn right and turn left. This pilot is an instrument, is a toolbox. So the future architect, we should not only working on the city by making research on the special project, but we can also make special like toolbox. The toolbox as a co-pilot together serving for the people and collaborating with human beings, human designers, then we can do some other things. So the future education for the academic world is not just teaching you how to make a design for a specific project, but also we should define the future architect as how to develop a special toolbox. The toolbox is kind of serving system for the future architect. So based on this kind of co-agent, co-pilot system, we're thinking about the future is a kind of a coexistence. The coexistence considers the new diversity, which is a mindset of human being and the non-human being. So this kind of coexistence is between human and non-human. I defined this last year as co-poiesis. I also implement this as a pavilion. I introduced to the Venice Biennale. I think it's a co-poiesis and coexistence is a certain kind of future on the planet. We should be rethinking the technological pilots or the agents, and we're considering the natural elements surrounding us as the ecosystem, and also we should consider the mindset of human being. So this kind of coexistence we should consider for the general background to AI, which is coming to us. So every year we make a lot of innovation, actually not just about a workshop, but also we publish a lot of papers, research papers by the PhD students, different research team globally. So CDRF is a computational design and robotic fabrication conference, which indexed by EI, and we already published 6 like conference books. So this year will be the 7th coming out. And also we put forward architectural intelligence as a topic from 2018, which make research on the 3 different scenarios, including the smart habitation and the virtual habitation and the spatial habitation. So these 3 scenarios actually will base on the human and non-human, the human intelligence and also machine intelligence that will give us a new paradigm for the sustainable development to the planet. And also the right hand is different kind of scientific questions we put forward, which can be implemented to all the research I will mention later. And also we have another journal named Architecture Intelligence, which also EI Engineering indexed. And we published like 6 issues over the past 3 years. So these also very popular, I think not just in Asia and China, but also from States, from Europe, from UK, from Australia. A lot of like academic researchers publish different new understanding, new research based on the architectural intelligence in the city level and in the virtual level, and also in the architecture physical spatial level. And so the team actually, based on this kind of global communication, we developed some softwares as a production, as a co-pilot instruments, which is like when we facing with different transformation over the past few years, it's really based on the software we develop. We not just develop or design projects or construct projects, but we also actually collecting all the PhD thesis and the graduate student thesis. We make them transfer them to be some toolbox. The toolbox subdivided into 3 categories. One is FU Generator, which is AI for architecture generation softwares, and FU Robot, which is robotic fabrication control softwares, and FU Sense is in-situ sensoring and feedback softwares. So based on these three software, we establish a special working flow, how we design and how we analyze the city for the future. So this is like I think the special attitude from the team. We are not only design the object, the city physical object as a research topic, but also we make research on this kind of virtual, this software, this kind of toolbox to enhance how we understand the planet and the surrounding environment. So these are the diagrams I put forward 3 years ago to analyze what is AI for architecture. I think there are 3 different main layers. The central part we name is like the general model, which is actually developed, announced by different AI scientists every month, every week. I think it's booming in the United States, in the western coast of the American society. They actually announce make a lot of promotion to this kind of general models. I think these kind of work could be only developed by the AI scientists, right? But that's not enough. As an architect or urban planner, actually, the narrow model is important, the second layer, which we should learn how to analyze, to make use of all these general models, to find the scenarios, to solve the knowledge from architecture and urban planning or the historical preservation, how to implement the general model into your special discipline. That's what we name as narrow model. So the narrow model is actually different university will establish your own toolbox, and different research team also have your own softwares. So as a PhD thesis or PhD student in my group, for example, we'll name it as a segmentation with some small models. Every PhD student should develop certain toolbox. For example, if you make the historical preservation or heritage preservation, you want to like censoring, collecting the data, you need to have some softwares and as well as some hardwares, right? You should establish certain kind of segmentation of small models, collecting the data and implement into their research topic. Does not mean you become an AI scientist. You are still in your discipline, but you must implement the general model to solve your questions. That's I will analyze how we improve in my team. So modeling, the model training and tuning are the main task or main job right now in the PhD study in Tongji University. Also, we exchange through the platform of Digital Futures all over the world. I think we have a strong connection to ETH, Fabio Scholar. They actually also doing the similar things. They have their own platform, we have our platform, but in the workshop, we can exchange ideas with each other. And also we have a connection to ICD and University of Stuttgart, to MIT, and to University of Michigan, and a lot of universities, global universities, we also sharing this all common ground. I think that's a general attitude, what I want to explain today. So the AI for architecture framework, I would like to say the general motivation, the design for sustainability, because the planetary issue I mentioned, we should be thinking on the climate change, rethinking on the data set, and how to categorize them to solve specific vertical model questions. That is the high level things is design for sustainability. The second level things, we need platform. The platform is co-agent, I mentioned. Co-agent is human being are the intelligence from human body, but after the post-humanism era, we go to the collaboration between the human and non-human. So non-human including some like intelligence from machine, intelligence from like AI, this kind of algorithms, right? So the co-agent generative design platform is important to augment it, our intelligence by collaborating with different developed platforms. So FU Generator is one of them. Is we establish as a platform, we develop as over 4 years. We're collecting different kind of special framework. I will briefly introduce the framework, including we also sharing the culture of open source. So open source culture in the computational world is extremely important. GitHub is important. Open source is important because every month when someone announces some general models, we will introduce them to our FU Generator. FU Generator establish an infrastructure system Right now, we have over 50 different algorithms as a fundamental infrastructure system to serve our design process. So we establish a system how to briefly or directly introduce the general model to the designers. The second, because we are architects, we are urban planners, we are designers, we have our knowledge system. So we establish different toolbox. We name is architectural knowledge graphic. We should establish certain knowledge graphics and connecting the keywords, the knowledge system, the images, and different models. We're training them, and that's the computational scientist or data scientist that cannot understand, because only the architect in your discipline is your own knowledge. You should establish your toolbox and data set to training your own model. That is based on the knowledge graphics. And third, but not last, is the custom design ecosystem. Because every architect will define your thinking, the ways of thinking, the ways of making in different ways. You have own customization working flow. So we try to design a special toolbox like Grasshopper for Rhino. So it's kind of reorganized the working flow by the customization toolbox. So in this special topic, we can assemble different general model and assemble different knowledge graphics to our design process. So this is a key framework we establish for the FL generator as a toolbox. I teach my students, undergraduate students and graduate students, all by this platform over the past 3 years. I think it's very useful to augment the design thinking. I will analyze to you. So in this framework, in this general model infrastructure system, we subdivided the general infrastructure into 3 categories, including the generative algorithms, including the optimization algorithms, including the prediction algorithms. Years ago, when human beings want to do some design is something to predict the future, right? You will tell them how to preserve a facade. You will tell them before the preservation how they will look like, from representation, from drawings, from facade drawings. But right now with AI, it's 1 second, one button will give you 1,000 solutions very quickly to predict the future. So the prediction is based on the algorithms. That is, totally will shorten the thinking process and shorten the communication process. So it's kind of revolution. It's not just a kind of optimization, it's a kind of revolution to redefine what is generative design, what is like optimization and prediction. So the working flow is the algorithm system. I define the generative optimization process and prediction with the 3 key aspects. We collecting different kind of algorithm models as infrastructure to serving our design. And what is training, tuning, and interfering? I think it's 3 main concepts. The training is important. What is the means of training? Training means if we design maybe 40 or 50 different urban design projects, for example. We have the urban planning site plan, we have the urban planning data set, we have the urban planning system, the green system, the circulation system, the habitat of the animal, of the different system. Based on, if you have hundreds, have dozens, you can put them all into the training data set. And then after training, the AI tools can understand and can emergently understand what you're talking about. If you give them an empty site plan, they will follow your training to give you the site plan simultaneously for their understanding of your design. So that is impossible before, but based on different AI platforms, it's possible. It's possible. So it's totally based on how many data set you have. It's not 100, 1,000. Normally, it's billions level. It's 10 billions or 1 billion. For some general models, this is based on all the data set. What's the architect that you have is not, it's impossible to have only 10,000 images is a big number. So we name it as a tuning system. It's not means you define the whole data set, some big models, but you can only training them by some small models. And then the AI can learning how to, after tuning to interfering to predict something in the future. So that is the very easy by the small data set, how the narrow discipline, like architecture discipline, with some narrow, very small data set can predicting the future, which is totally based on collaboration with big model. So that is the three very key concepts: the training, tuning, and interfering to our world. So this is last year, actually, before the end of last year, we actually import 43 the general model in our FL generator, but until now we have over 50. So that means when someone open source their general models, we just introduce to our platform. So that is based on the open source culture. That's just a kind of reprogramming and connecting these big data to our working flow. So this is very important because as an architect or as an urban planner or as a designer, it's impossible for you to train billions of big data set of this general model, but you can make use of them, right? So this is how we categorize them in different ways and to introduce to our system. This is general foundation, common ground for our FU generator system. And based on that, we constructed a multimodal library in the FU generator platform. What is multimodal library? We have the text to text, text to image, image to text, text to image and the videos, text to image and models. That's a lot of general models like ChatGPT, like the Blips, like DeepSeek, this different kind of general model. And they can actually help us to salute, to facing with different kind of motivation. So this is designers, we can make different options to assemble all these kind of multimodal algorithm in the working flow. That is important. So in our FA General platform, we introduced the blue part, the dark part is around 20 different kind of multimodal transformation toolbox and algorithms. And based on that, we can communicate with AI. We can ask some questions, we can send different prompts. We can also make some sketches and also we can input different images to this platform. And then they can help us to predict some images or models for our design. So that is totally engaged into our working flow. And every designers actually have their own thinking process, maybe different curvature and in different special process. You introduce different general models. It's free. So how can we design a certain very creative design based on different working flow? That's the future. It's not just by the human imagination, it's by some augmented or enhanced design toolbox in input to your working flow. So this is different working flow as an AI assistant to FU generator, our platform. So the AI assistant actually, this kind of multimodal LLM, large language model alignment approaches, which is totally based on the input encoding process to the output generative process, which is based on the very big large language model and the latent space creative process. So the latent space is based on the generative process by the data set, right, in the middle. I will analyze more this is the website and the interface. And also we're training different kind of small models by different users. We have 4 different kind of categories right now, including we input prompts and generate the images. And also we can input training our data set by the tuning process. So this is one-stop cross-model integrated process we design. Also we're training our knowledge graphics. For example, robotic fabrication. We have knowledge graphics, historical Renaissance era, how to redefine the Renaissance buildings. We can train a data set. So that is something based on this platform. Interface. And also we can make videos. So from that's more clear ways to analyze this process is totally based on how the knowledge graphics was built. So actually in our Tongji Design Institute, we developed this general platform. We're collaborating with some historical historian and the theorist. They actually don't know how to train a data set. It's just, for example, we invite Mara Kapo, who is a professor from UCL, London, and come into Tongji and teach he will teach the workshop, digital workshop this year. And he have a concept he wants to collect it because we have a library, over 1,500 Renaissance historical books there. So he wants to collecting what is Palladio's design in the Renaissance time. And he wants to scanning all these kind of buildings firstly, and then drawing some diagrams, make a lot of research diagrams on the Palladio building. And Mario also would like to training a Palladio toolbox to design. If you give any plan, and this software will generate the facade and also modeling the 3D space based on the Palladio's game rules. So that is a training process. So that is totally based on the database. How many data, how many plans, how many facade, how many diagrams you can collect it to a certain topic. And you should label them. That is most important. Label the proportion of the facade, label the elements on the facade, or label the scale on the plan. And that is super important. So that is some knowledge part we name as knowledge graphics. And what's the logic between them? You should define them. So my toolbox, FU generator, I'm not a theorist, but I can collaborating with Maria Capo to develop a Palladio special toolbox. And this toolbox can help us to understand and to create something based on Palladio's knowledge. So that is something as an example to influence what is database and knowledge graphics. And in this process, which is super important about what is the perception of architecture knowledge, the knowledge is very important. We should first define this knowledge, or after there's some database, we can analyze some knowledge graphics, or maybe during the interfering or predicting process, we can label the knowledge in the process. There are 3 different ways how to make the perception and the index, and how to embedding all this knowledge in the data. So this is very computational knowledge, but I think which is important, collaborating with different professors and different group of peoples to train our vertical FU generator toolbox. And this is the working flow. The most important is expandable. Expandable is important because it's should not be a totally black box system. We should also go back and forth to analyze if the prediction is true, it's not doing something bad or doing something wrong. So it's traceable, and it's iterationable, and also interactively could connecting with the designers. And based on that, my group developed a certain toolbox we name as Unicorn, which is like a plugin toolbox. It's like if you know how to use Grasshopper in Rhino, so it's like the Grasshopper for Unicorn is a Grasshopper to FU generator. We can define all this working flow by this toolbox. You can see this is a demo for our Unicorn in the FU generator. So Unicorn is we're defining these general models and knowledge graphics, and connecting this data and putting 20 images or 200 images or 2,000 images in different database. And what kind of algorithm, general model you implement in the process, and how to make a category and make some interactive defining process to the defined result. That's totally based on this Unicorn process. So my team is developing the softwares, the platforms, but we cannot define the knowledge or data set. We're collaborating with different people, different designers to training this platform. That is what we are doing. So this is an open source general models as an infrastructure, and we develop right now over 50 vertical models for architecture design. And also we define different knowledge graphics. So knowledge graphics is by labeling from the prompts firstly, theoretical prompts, different hierarchy of the concepts. For example, in this summer, we'll make research on Palladio, and we should make research from the historical context, or from like not Palladio himself, but someone else, and how to define the crafts at the at that time, and the decision-making process at that time, and how this plan or this kind of structure system is going. So this is a knowledge graphic system, and we should define them and make diagrams on that, and training them to the FU generator, and machine will learning how to define the hierarchy of the knowledge system and database. So this is the mathematical part for FU generator we develop. And also in the future, we are looking forward to collaborating with design company, architects, and architecture students. So more is better, because more training will make the FU generator more strong. They will have like different skills in the design process. And second software is FU Robot, I think, which is robotic fabrication control platform. We can transfer the geometry all the way to the toolpaths of the robotics based on this software. We developed over 8 years on this. So that means this is the software interface on the left, and the right one is we can simulate all the 3D printing or timber fabrication process, transfer all this geometry all the way to the printing toolpaths. So this is also a software we're working over the past few years. And also in our lab, we develop this kind of hardwares, including prefabrication and in situ construction. The left one we developed in 2015, and the right one we developed in 2019. And also we developed over 15 different kinds of crafts, including 3D scanning, steel weaving, and also the carpentry crafts we developed. This is in 2013, we developed a timber fabrication hardwares, including the tool robotics on the track, and totally 14 axis. We can fabricate anything based on that, including the Valentina project is based on this. Actually, the toolbox was developed 12 years ago. So the last 12 years, we're developing softwares and learning how to collaborate with this machine. They are the co-pilot to the designers, but how to make use of them is need a long-term training, and learning curve is very slow actually. And in 2015, we developed this platform, which is like 10 years ago. We developed this kind of Genshi robotic system. We can fabricate very large-scale projects based on this. And this Hong Kong M+ Art Museum collecting one piece of the mockup, actually, which can, it's kind of circle we define, and fabricate each pieces of brick, and based on rotation degree of the bricks, actually could be fabricated by robotics. This is in situ. This is actually the 8th generation. Right now, we all the way goes to the 10th generation for the mobile robotics. We can move in anywhere to the construction site, right? And these also another kind of matter printer we define. We integrate 8 crafts in this machine. We can transport by a truck to any construction field in China, which is less than 3,000 kilos. One project, just 6, this kind of machine can fabricate a very big building. And also we develop drones, which is important with 3D printing and construction bricks by this machine. This is one of my PhD students. So we developed not only the hardware, but the software, and how to like censoring the city by this machine. So all this kind of development in the architecture school right now. And this in Singapore last year, we teach a workshop. You can see based on this platform, we can make the fabrication very interesting, very accurately. By the special degree, the hands can put these bricks on that. It's 2 days workshop, very short, but we present the certain kinds of technology. These drones can accurately engage into the construction industry. It's by my PhD students. So also 2 years ago, in 2023, we have Jean Pauvet exhibition in Shanghai, and the curator invited 6 architects to make a feedback design on Jean Pauvet's chair, which is super famous on the left. So they gave us only 2 weeks. So in the 2 weeks, I firstly introduced this model to the FU generator. The first, I established the question. We keep all the legs and redefine the back and the seat. And the right one, we keep the back and seat and redesign the legs, right? So this is an AI generative process. We're training the data set by 2,000 famous chairs. And then the creative process, we define this kind of softwares. We can generate hundreds, thousands of different chairs, which have a dialogue, have a respect dialogue to Ramp-Purvey. So this is a different age, different industry, different production process. This is not enough, because after we generate different chairs, how we can making this in a very short time, only 2 weeks, right? So these are the chairs we print, make option. Because it's time very intense, but we make option super fast. The left one, we keep the legs, the right one, we keep the back and seat. So to reproduce 2 chairs as a dialogue to Ramp-Purvey. And also my office, sort of printing different kind of chairs. This is not a rendering, it's a real chair, so we put on the river bank. And these chairs we collaborating with Nike, because Nike shoes, they will 40% of them will be recollected after new chairs going to the shop. So we're collecting all this kind of waste material to printing the chairs. This is one of my students. In my studio, we designed the chairs based on the topological optimization process, and this piece is collected by the Pompidou Art Museum in 2018. This is my studio, actually. We implement FL generator to ask every student learn as a very beginner how to training a data set, because the chair is the most easy part. They can collecting all the chairs you like best, and they can input your sketch to this FL generator to change any style, any proportion. And in 8.5 weeks, half semester, they should not only design a chair, but also making a chair in 2.5 months. So that is a great challenge. They are not carpenters, but they can learn how to implement robotics, help them to fabricate all these chairs in a very short time. So these are design process. They optimize the skill of the elements, and also rethinking on how to fabricate them by different components, right? And how to save material to make it more low budget. So the student is not a carpenter before, but it's good to educate them to collaborating with AI toolbox and robotics to how to design and making something for the future. That is the discipline change, I think, which is totally the revolution we define rethinking. And also we make research on some different algorithms. We can generate the structures, compression, tension. This is one of my PhD students leading the team of graduate students. They're 3D printing all this. What is compression part is concrete, and tension part is a steel, a steel plate and steel valves, and fabricate them in 2020, which is COVID time, but doing some research on this. Yes. And then after that, we go into the full scale. So this is a bridge based on the same methodology we printed, which is 60 meter span, 60 meter span. And we can 3D printing component by component, and then to input all these elements in the on-site. So you can see the video, how we design, which is like an underground parking area, but which cut down the connection between the city corner to the park. So we try to bridge them this with 60 meter span. So this is structure system, how to analyze this kind of connecting and generate the form by the structure performance and by the topological optimization to reduce the concrete weight, right? And followed by this kind of force flowing process, we generate the form. The net span is 45 meters. The outer span is 60 meters. This is working flow. We translate the force flowing to the 3D printing toolpath. So you cannot imagine all these designs actually is the architects leading and structural engineers just follow to prove you are right or wrong. And you can control not only the form, but also control the construction process as an architect. And this is a construction process. Yes. We 3D printing all the components in the factory, digital factory, and then transport these concrete 3D printing elements to the construction site, which is totally based on the working flow and the force flowing in a very accurate way. This is after construction analysis. This is an infrastructure system, totally concrete, right? But it's based on this kind of formation process and the 3D printing process. So every year as a culture in Tongji, we construct a bridge. This is 2019. We're 3D printing a steel, welding a steel skeleton support system and some glass fiber and carbon fiber handrails. And these are the ultra thin 3D knitting as a support system. UHPC, we're spraying only 3 to 5 centimeters to create a shell structure to support so many people on this. But we also test to failure in 2023, a concrete which is crashed down. In 2024, we make a bamboo bridge. We design all the joints and all how to connecting the bamboos. And these every year we make a tower as well to make research on the wooden pagoda in China, Yinshan Muta, which is a Song Dynasty, a Ming Dynasty pagoda tower, and make a research on that because from outside looking, this is only 5 stories, but the inside actually there are 9 stories. So they hidden some structure transformation layers. So we try to design by graphic static study and how to transform all these forces by this kind of timber structure design. So on-site work only 2 days and 2 nights. We implement VR. This time in Venice Valley also implement similar ways to position each pieces of the timber on the right way without any nails this way. Yes, it's accurately by the 3D scanning, by the 3D positioning of the elements. You can see here, there are 9 poles in one joint with no nails. It's all accurately positioned them by defining the geometry from the robotic fabrication. And from the VR, we can understand which components position and put them, the workers and the students can put them very accurately by this special toolbox. This is a fabricating process, totally by the 3D modeling. And also the milling process is very accurate, very efficient. You cannot imagine such a big tower in our school. We spend like only, the prefabrication we spend 2 weeks and on-site work only 2 days and 2 nights. So that is workshop culture. The workshop is not something like just face-to-face meeting. It's about research, pre-research, and establish some certain kind of platform and toolbox and can implement them and update year by year. So this time in Venice Valley, I will introduce tonight, is also the same technology we developed over the past 3 years. So the how efficient. Carlo gave me only 1 month to prefab in Shanghai, which is very big, 40 meters long, 400 pieces, components, timber components, only 1 month, but we prefab them super efficiently. And on-site work only 7 to 8 days in Venice, super accurately by the VR glasses to position them. So technology, we prove a lot by the workshops. The workshop is a culture to make research for the future, and the toolbox we develop is super important. So this is the last image for the tower. Actually, we start learning how to carry and how to milling by the robotic teams. So these are the working flow. Actually, every year in my team, we have a competition to design the Christmas tree at the end of the year. This is 2023. Every January generate some Christmas tree, a shining Christmas tree like this. And after 6 hours, we're 3D printing them like this. So this is the new industry. I think we predict for the future as a designer, what a designer can produce in the future. We can produce not only some like elements more, but also can produce some like architecture skill things by the AI tools and also the robotic fabrication toolbox. These are the auditorium in Tongji. I designed it, and only the summer vacation we have time to remodel this space. Only 2 months. So we 3D knitting all the ceilings and 3D printing all the walls, and also we design the chairs and 3D print the table by ourselves. So it's all my PhD and my teams. We will make the auditorium renovation. So we prepared this for a long time, but only 2 months on site to make everything settled down. This is 2023, 2 years ago, in the urban renovation project in Shanghai. You know, the Shanghai climate in Shanghai is extremely hot. So I think the future for the very eco waste in the construction site is not human body. So we prefab all this facade bricks in the factory, and on site only like the cranes and only 2 or 3 people, they can implement all the cranes, how to install the facade system in a very short time. So in the extremely hot weather, how to accurately construct the renovation, the brick facade system in Shanghai. This is in another building. Also, all the elements are prefabricated and produce design. Okay, this is last year. I got invitation to Buenos Aires Biennale in Argentina to present one of my project. So in that exhibition, my topic is non-local locality. What is non-local? Non-local is like a planetary culture. The global technology is there. The hardwares, the softwares, we should open source all this technology as a non-local element to the discipline, to architect discipline. Locality is something culture, like in Torino, we have your local culture. In Shanghai, we have our local culture. So how to find very sensible locality from architect perspective is important. So the global technology for the milieu of Fengtu is kind of local culture in Chinese. It's very important. I think it's kind of, on the one hand, global technology, on the other hand, it's milieu of the Fengtu, which is super important. This is in Chinese garden, the most famous in Suzhou. If you have time, you have special occasion, you should visit this. This is Dian Chunyi, which is a master of nest garden. The Luca Moliani is from Milano, who used to curate the Milano Trani. And he curated exhibition in this exhibition and invite Zhang Li and me and another professor from Southeast University, 3 of us, make 3 pavilions. This is my design. It's a very important scenario because this is a Taihu stone. In the back, this is a real Taihu stone in the Ming Dynasty, around 500 years ago, at Renaissance time, right? They're collecting this kind of Taihu. It's very rockery with holes, stone, natural hole, stone there. And in the middle is Ming Dynasty. In the back, actually, 150 years ago, because this kind of natural wood is super expensive. They have no money to buy this real one, so they carving the big stone into a stone. This looks like a Taihu stone. So in the contemporary time, we use recycled plastic, reprinting something by Houdini. This is softwares to modeling them and 3D printing them in a very short time. I think this is kind of dialogue. The same image, same culture, same like semiology is kind of representing their cultural background, but actual technology change. material is changed, right? So you can see what I sort of printed, people like to sitting on it, lying on the play with it. So it's kind of new culture to the rugby culture in China. And this in the Vance Biennale 2018, I also present this model to the president. It's like a table long. Right now, this model was collecting by New York MoMA and Hong Kong M+, two different copies, to present a certain kind of Chinese pitch roof as an object, but actually which can be only fabricated by robotics because it's kind of double curvature, continued roof system. I name it cybernetic tectonics. These are in Shenzhen, curated by Chelly. So we did something there. This is like 6 years ago, what we've done. Take a look. You still remember this? My PhD students is doing something like this. So this is the Vance Biennale 2018. So we actually implement this kind of digital twins to simulate and real fabricate by robotics as human being. These are the scripting by the FE robot, actually. 1 second, everything coming out. Very accurate, the collaborating between the human designers to the robotic fabrication. It's a real building, very local. We name it like local buildings, but actually you can see all this kind of geometry system. This building was constructed in 2017, 8 years ago. Okay, and also I would like to introduce my studio, my office. Actually, half of my time stay here. It's a warehouse renovation area in Shanghai, very close to the riverside, and 3 spans of the warehouse, and also we have a robotic hub here inside it. So this is Silk Wall we constructed in 2009, and this is 2022, I think. We recorded a special video for the environment. The trees are still there, it's original trees. I helped the ceramic artist to renovate the building like this. This 1-story building, we're adding a building inside the old walls. This is my studio. And actually, this is like 15 years ago. Oh no, more than 17 years ago. I working with two local masters. With names, they're carpentry and also brick mansion masters to construct this in a very short time. And this is 2015. We have our research lab inside the warehouse. 2009, 2011, 2018. And this, in the middle of the courtyard, they invite different expertise teaching with me. I was got the invitation to be the visiting professor to MIT with Philip Block. So we have a visiting studio from Cambridge to ETH and to Tongji. So this is shell structure we developed. So the contribution from my team is 3D printing this scaffolding with no timber scaffolding, only the support by the 3D printing elements, and construct 3 layers of bricks. 6 months later, I implement this technology to a 45-meter span, huge pavilion in nearby Shanghai as an international conference. So the nest height of this shell is only 45 centimeters, which is 1 to 300, which is 3 times thinner than the X. So it's ultra thin structure. And also we demolish to construct something new. So you can see this is super ultra and actually use very small amount of materials to construct such a big shell. So after demolish something like this, yeah. And we construct another pavilion. As a visiting professor from RMIT, I teach a group of RMIT students from Melbourne to Shanghai to construct this. I teach them how to design the bridge. So we published a book on the intelligent force printing. So this video showing the process. This is a graphic statics study, and computational graphic study is a very strong softwares we implement years by years. For the tower, for this is all the graphic statics study, and transfer all this to the 3D printing technology. From virtual to reality, this is digital twins. We simulate and real printing them. All this work, all this pavilion was constructed by my student. They put some steel plate inside for the tension structure. This is a 3D printer. This is 2021. attention. Okay, this is like very small courtyard. It's a research office, and after typhoon, it was blown down 2022. 2022, yes. This is something happened there. So we want to reconstruct our courtyard sitting by reuse the material, broke down material, how to reuse them to construct this kind of structure system. So we collecting the lens, because every piece has different lens, right? But we want to reuse, how to reuse them is also designed by Graphistatics. So this is like 30% new material, but 70% are recycled use based on the AI toolbox to augment it, how to position the right pieces based on the graphistatic study. So we totally make use of short pieces from the crash down of the ceiling system. So you can see how to cut down them, collecting them in different ways. So the longer one was new material, but the short red one are all the reused material. So this is after the new construction. It's not the symmetrical one is all different, but it's generated by AI. So very quick go to last year in Buenos Aires, Argentina. I participated biennale by one of my projects. So this is the land restoration in Nanjing. Used to be a ceramic factory, a cement factory, and we built and restore the landscape and build a very special hotel. Just very quickly take a look. There's a rendering. There's a real construction after finished construction. This is a big project, totally over 50,000 square meters. Exhibition, drawings. I want to introduce is a very special for the lobby. It's a huge lobby, 45 meters, 21 meters with only one column I designed. It's one column support the whole sitting. So that's a great challenge, right? How I generate the form is totally by the structure performance formation process. We introduce the sunlight in the daytime. You don't need to turn on any light. It's only natural daylight. From the roof system all the way to the structure system to support the whole lobby. So the timber like this is, we're very good at like 3D curving all these timber elements, right? This is a rendering. This is a real construction. The rendering, the real project. And also the pickup and the drop-off place need a very big cantilever. The big bus should stop at this big hotel. So it's like a paper. If you're curving them, you can cantilever, right? So we introduce this kind of structure technology, make the curvature pitched cantilever roof system. I introduced two labels to hanging all these curvature timber elements for the entry roof. So you can see there's two cables, also curvature timbers. After construction, something like this. It's very big cantilever. And also the very important part I want to highlight is the facade. Because of the cliff, it's something like, in Chinese painting, it's like the two-stroke make joints by the water and the ink, right? So how to fabricate this kind of artistic or this kind of facade system? From certain perspective, it's a continued drawings we generate by AI. It's like the the training data set, right? We project all this to the facade and to the brick system. And robotic, we introduced 4 robotics for 6 months to fabricate all the very big hotel facade system, brick by brick. So after the facade finalized, you can find this have some arbitrary rotation, but very accurate, the global geometry, right? Which is sorted by the human-machine collaborative process in the real architecture industry. It's after construction. You can see the roof system, facade. Okay, very quick, see the last project, too many projects. So these are AI generative process. We introduced to design the snow which melt in the spring. This kind of poetic process, design these buildings. So this is AI generative process. We communicate with the client and how to position the entry, the semi-open public space. So this is continued boundary located in the rural area of Chengdu. This is after construction, something like this. So this is the largest 3D printing roof in the world. We first produced. Yes, you can see all 3D printing, the roof system. And also the timber, it's a reciprocal timber structure system for the buildings. This is Rubin and the facade. This is not rendering, it's a real image. The all facade is reprinted by the super big cantilever. You can see the elements, yeah, reciprocal, it's all different. The joints, very accurate design. The generative process, this joint design by this machine. So the most highlighted here, we accurately design every component, totally 1,064 timber components. Double side, we should milling them as the joints. We have over 4,000 3D panels on the roof, one by one, 3D printed, but every piece is like this. So it should be very accurately generated by computers, right? And also we implement the BIM to simulate the different system, how to construct in the process. Layer by layers, installation, waterproof, and structure, substructure system, roof system, right? So on and so forth. So we name it digital tectonics. So this kind of AI generated form, how to translate to structural system and to the fabrication process. So this kind of tectonics is kind of real representation of material itself, including timber is timber, steel is steel, and 3D printing is 3D printing. This kind of new tectonics we introduce. So the left one is virtual rendering, the right one is reality. So it's kind of accurate control for the whole process. And also we should design the process, different layers, the tectonic layers of the building technology. And every day I can review this kind of drone scanning files and to compare to predict if it's accurate in the construction process. So after construction, something like this, so it's a kind of new buildings we constructed in the post-humanism era. I think it's new material, new technology. Actually, still we are doing something for the new architecture. So that's my lecture today. Thank you.
Maybe just because they can hear from far away.
Yeah.
Oh, thank you so much, Professor Yuan. I think it's been an astonishing presentation. You almost killed us in the way it was so many points of discussion. Thank you a lot. I have some questions, but I guess first the PhD students to raise some questions if you want. The only thing I ask you, or you raise very a lot the voice so we can record also the discussion. I think it's very important. And maybe I have some comments, but later.
Yes. If you have some comments, it's just if you can just go there and yeah.
Raising the rest.
Maybe you can just stop the sharing.
Okay.
So we can...
You can see the screen. Here we go. So you can hear us, right? Everyone?
Okay.
Okay, there we go.
Like, first of all, after your presentation, I don't feel anymore as a PhD student because your PhDs are like a quite high level. I have many questions, but I'd like to start from your like the story when you start about the toolbox. So it seems like your PhD students are already ahead of different disciplines. But did you ask them like before to have some sort of knowledge to understand these kind of tools? Because like based on our education, we don't either know programming or Python or any large language model training. Like how the PhD process starts in your side?
Yeah. I have, right now in my team, I have 12 PhD students and 5 postdoctors working with me. And most of the, I think 50% of PhD used to be my graduate students. Mm-hmm. And 50% outside. And we know each other actually, including my master students, I think mostly from Digital Future workshop. Because I think the workshop culture is very important because it's like a iterational process. Year by year, the students can learning a lot, not from the normal studios, but the workshop can teaching a lot, including the scripting. If you notice the scripting is important, maybe after the students going back, they can learn some like scripting courses, Python or like C#. They can learn how to, not Java. The professional computer scientists use Java, but as an outsider, like we make development mostly on Python because it's user friendly. So I think you should learn scripting. Learn scripting is very important before you go to my team, I think, as a PhD student. So normally before they enter, they should waiting, because a lot of people want to come inside, they should waiting for 1 year or 2 years someone, they should start learning some scripting as a fundamental knowledge, because everything, if you want to design, want to develop toolbox, the first step, you need to learn how to scripting. So that is super important. So I think we built a certain culture to collaborate with the computer scientists, introduce the computational design into the academic discipline. That's what we have done over the past 20 years. So I think that's the first, very important. The second, I think it's kind of culture we base on exchange knowledge and communicating with not one university in Tongji, but with the whole world. So we invited a lot of groups, including MIT, TH, including ICD, UCL. I think all this kind of top universities around the world, we're sharing a lot of common ground, because we found this important to contribute to the knowledge innovation. The innovation of the knowledge is not just about the design studios or design the project or make some research on one project, but more about to understanding deeply as some common knowledge or common ground on not only one project. This common knowledge could make some solution to multi-projects. So what is the common knowledge? The common knowledge, on the one hand, is based on the historical vision perspective. It's based on we name it like the discipline knowledge by a professor. That's all the traditional there, right now is still there. Maybe through the diagrammatic research and through the like different drawing research and different kind of like different books you should read, let's say. But additional to that, we need to learning. I think all these kind of universities, including UCL, this summer we have 3 teams from the UCL coming to Shanghai teach workshops. I think they have a long-term culture, make research on this kind of toolbox culture. They develop toolbox and to implement this to solve certain problems in the project. So this is like a transformation between the human and human. We have something in between. Between the human and nature, we have something in between. What is that? That is some like we name it a co-agent, a co-pilot. That's something like very computational. or robotics. That is between us.
Sure.
And we can share in this research with different people. And we can update year by year. We can make better and better. The first year maybe it's very naive.
Right.
The second year it's better, and third year you're very good, excellent research. So that's based on very specific topic, maybe very narrow topic, but it's good to look in each other, what's happened here, there. So we are learning from each other. So that is something we built over the past 15 years.
Can I ask more? And like when you were saying about the training and tuning parts, which type of data sets you define project? Because like a project can be based on many things.
I think this is a very good question because the expertise are from different research topic. If you are a landscape architect, for example, you have a lot data set on the greeneries, on the natural system, ecosystem. So you should define your database. So what I develop is a common training process or training toolbox. You can build your data set. You can implement the global general models, implement these general models to training your data set. And in the data set, I think it is important to label them in different ways, to label. For example, this is iPhone. When we label them, this is black iPhone. This is Max iPhone. This is iPhone 15, or you can give them different labels. If you planning an urban system, you can label this is a lane, this is 6 meters width lane, or this is curvature lane. You should give labels. Labels is when you training the data set. Maybe the training process is no need to be big numbers. It's not billions. It's only sometimes we training 2,000 images, but every images we will label them. So I think this kind of label process should be by some professional people, because if you're a computer scientist, you don't understand what is a city. You don't understand what is a chair, how to design the chair. The ecological curve and the scale, the computer scientists don't understand that. But as a designer, you understand the rules. But you can label them in your own way. That is important. So we have big data, and the most important is not big data, it's the labeled small data. We can tuning them by a very small number to influence the big number. So that is the epigenetic what we have done before.
And like when you were making the simulation for the bridges, have you ever tried a simulation based on cities to, I don't know, like find a living machine for traffic solutions, for weather solutions? Have you tried the simulation on city?
That's a good topic. Sometime we should narrow down the research on certain topic. As we design a bridge, the key knowledge is from the structure engineer. It's like graphic static study or topological optimization study, which is an algorithm developed by some structure engineer. But my good friend, for example, Philip Rock, Mike Shear, is all the top structure engineer around the world. All of them have their own algorithms. And we can introduce all the structure engineer elements to the design process. We can implement them to generate the form. So the key form, the curvature, is from the structure engineer. And from designer's perspective, is a skill. It's a decision which point to point, how to connecting with them, what's the width of them, the width, and also the materiality. These are the designers we can done, and also the crafts, the details embedded in the crafts, and we can define these things. So it's a multi-motivation decision-making process. So that's why we assemble all this knowledge in the whole process. It's not one rules, one motivation. It's multi-motivation. You should balance by the design.
And to conclude, so somebody can ask, what is your next target toolbox? What you're planning to do?
Actually, we developed this three toolbox: FU generator, FU sense, FU robot, around 8 years. I think Grammar Scholar also introduced, they have Compass in ETH. ETH make research on Compass more than 10 years. I make research more than 8 years. So it's not changed a lot, but we just introduced the new knowledge into this toolbox platform. It was built by dozens of PhD students. Maybe in the future, we have like 30, 40 PhD students. Their knowledge are all into the softwares. So we need some collaboration. We need sharing with others. Because only based on this way we can like expanding our vision. Yeah, that is like the different group of universities. I think we appreciate a lot to ETH because this time in Venice Valley we're neighbors, and another neighbor is is MIT. So I think this kind of sharing the technology, the ways of sharing the technology is what Carlo actually embedded into this expansion. It's not just about the object, it's about what's behind it. True. How to make intelligent futures, that is the knowledge making and creating process. It's not just creating the object, which is about creating the technology platforms.
Maybe the next one can be Politecnico.
Yeah, thank you. Thank you for the question.
Thank you.
Welcome.
Yeah. Okay. Yeah.
Yes. Yeah.
Here?
Share on screen.
Yes.
Yeah,
Okay.
yeah.
So first of all, thank you so much. Something amongst all the interesting topics that I heard today from you. Something that I found quite interesting is how you referred to. It's not AI. It's something that how you refer to the knowledge that you've developed through the platforms, through the relationship with your university, and through the PhDs and the postdocs that you have, and how, I heard a lot the connection between PhD postdoc knowledge. It's something that I find super interesting and useful to consider. But my questions are two. First, would you say that how is the expertise changing in the making of a project where AI is so embedded into practice? And the second is where would you trace the difference in methodology in the process of making a project? So like how AI enters, which is also related to expertise, I think, but I don't want to. So yeah, it's like a twofold question where on one end, how is that human expertise changing? And on the other, if one were to consider critically their own practice, their methodology is changing because of AI here and there?
Yeah, it's a good question. Actually, I also a council member of UIA, United Nations for Architects. And 2 years ago, I make a proposal on AI for architecture. At the very beginning, like some council members from France, council members from Africa, they say no AI for the architecture, because PPC is a professional practice architects. It's a small group. The whole world, the council member is 28. Everyone represents one country. It's all over the world. When we make the discussion, I try to persuade them to accept. We need to introduce AI to architects. 2 years ago, it's like there's nonsense. You're talking something not good to protect the authorship of the human architects, because the human architect's office, you have your signature authorship, right? If AI learn your style, then AI will represent a design in the future. I think most of them are, at the very beginning, don't agree on that. But 2 weeks ago in Barcelona, they organized UIA council meetings. I was the only one to have opportunity to make a proposal to the whole council members of UIA around the whole world. Zhang Li is there. Zhang Li is a vice president of the UIA. And in my proposal is the accord, that's the guidelines for AI for architecture. And most of the council members accept. I think just after two years, most of the council members around the world in UIA accept or agree on we should introduce AI to the discipline. This very emergent, but before we introduce AI to the discipline, we need to establish certain game rules. Otherwise, they will demolish. Yes. So what's the game rules? We make a lot of discussion. The first we're sharing with you is we still believe in the human architects should have the key authorship. You should make the decision. It's not AI make decision, it's you yourself make decision. So that's the first, the top one. Rule one, yes, right? Everyone agree on that. And second, how to sharing the data set with the others, because when AI have the data set, they will know everything. They will training. In China, because Java office is very stylistic. Patrick Schumacher is good at that. So I was invited, I got invitation to be jury for several times for the huge project in China. Sometimes we just guess because we don't know who are they. We guess this is Java office. But actually when the competition finished, this is not Java. Java is that, and this is not. But they are doing some design, more looks like Java than Java office. Why? It's because this kind of stylistic image is everywhere on the internet. You can training your data set or rendering machine, learning this kind of stuff. So I think the ways for the future authorship we should consider, maybe it's not a stylistic way to define yourself. It's dangerous because it's very easily, your concept could be stolen by the others if you just the images to make the design. So this everyone also agree on that. So we should reconsider what is the key aspects of the key authorship for the future architecture discipline, how to define them in a different way. That's what we're thinking. Like Himmelblau from Austria, they also have a small group of people that training the sketches of Himmelblau to some data set, and also can make design, generate design, very Himmelblau style, but it's still very dangerous because the machine is much better than human being to do such kind of job. So I think this is something we should, so from my perspective, what I'm doing is we develop some platform. Everyone should have your AI assistant in the future. Every office have your AI assistant in the future. You should training your data set by yourself by some small models, not big models, by some small models, by some small amount of the data set, and how to label them in a special way, the first. Second, the working flow, how to introduce different smart agents into the design working flow, and define your data set, define your working flow is the most important. Because the whole design process will be shortened, will be very condensedly in a very short way. So what's the future job for architects is how to define the question, how to make communication with others, how to make the communication with the community, with the city mayor, yes, with the client. That's the job for architects. Because the design process is a very, very condensedly, intensely compressed. Yeah. For example, surrounding Tongji University, 5 years ago, we have over 500 rendering companies for the architecture industry, which is the biggest architecture design industry in China. We have more than 500 rendering or video making companies. But right now, if you want to looking, there are only 1 or 2 companies left because all closed down. Because we don't need rendering by the human-centric office. AI can help us render everything in very short way, short time. When we make a competition, my office only keep like 2 or 3 days for rendering right now. It's no need to keep too many time because the rendering machine can help you do everything. Small videos, maybe like 10 seconds to 15 seconds, could be like the video could be made by AI. It's super efficient, right? Yeah. So that's the working flow is changed. The ways how we're training the future architects change. It's not training them how to make a rendering, it's try to train them how to thinking, how to communicate with others, how to find your knowledge, the key knowledge system as an architect. I think that becomes more and more important. So I think that is how to, I don't know if you answer your question, because a huge discussion is the ethical problem for AI is coming because AI is too fast, too strong. We can imagine 5 years later, everyone should have an AI toolbox, maybe not one AI assistant, but as an office or as a research group, you have to build your toolbox system, yes, to represent you are different to the others, right? So that is the emergent issue to introduce AI into all the disciplines right now. I think that's why the topic for the multidisciplinary is intelligence, I think, which is a good topic because no matter you like or not, it's already coming. Someone can make these better things based on collaborative, someone just controlled by AI. You're going to very stylistic way because they're very stupid because you're controlled by them. You can only do some like images. You can not jumping out because you're controlled by the toolbox. The toolbox control you, it's not tools control the designer, it's not designer control tools. So that's like a computational, it's like a collaboration process. How human being can define the problems, define the working flow, define the new style. Actually based on different kind of like human intelligence. Yeah. So that is the challenge right now coming. So I think your question is super good. And I don't have the answer to that right now, but I think we should, yeah, we should.
Very interesting answer.
Yes.
Thank you so much.
Thank you for your question.
Thank you for your lecture. At first, it was really interesting. I found brilliant the beginning of the lecture about the new humanism, and I also saw inside the presentation your ability to link what is the vision and what is the technical feasibility for reach the vision. And I want to step just into the question is about the open source. I just want to know if your platform had something like a Git repo somewhere or something like that. And I saw a lot of model inside, something like vision foundation model and multimodal models. And I was just want to know, are you let in also the so-called open weighted diffusion models or multimodal model, or you are just looking for the real open source model, so you have a data set, the source code, and the network weights?
Yeah, good question. Actually, we ranking them at different level. The first is the higher level is open source. That means all the scripts you can copy and you can scripting on them. The second level is open use. The open use is like the GitHub. You can like wearing a suit on them, but there's a toolbox, you can freely use them. I think what we are doing is the second level. It's on the GitHub. We set everything to the GitHub. Our best software is FERobot because we already put it on the GitHub more than 6 years. And the users, I think we're ranking the top 3 in the whole world of my FERobot software because we control robotics. That is freely, we charge nothing, totally free. Why we want to do that is because we achieve a lot by the open source culture, open culture, sharing culture. So what we want to contribute to the community, that's why a lot of people admire our platform, Digital Future platform, because we open what we have to the users. If you buy, for example, if Torino buy robotics, you can freely download FERobot and you can control them very easily. You can standing on the shoulders of us to make further development. You save time. You don't need from the bottom every lines of script writing because we have 200,000, more than 200,000 lines of scripting. You don't need to do that because we're sharing with you. That's the most important is if you make decision, would you like to go this way to doing design or organize your teaching and organize your practice. So that's the most challenging part actually. So the second FE generator we also open is FEgenerator.top. I think we will update every 3 months. So right now the version maybe not the newest version, but every 3 months we update the data set, training. Every 3 months we update the version and you can use it. So in China, because we have 2 languages, Chinese and English, 2 languages, but most developers in Chinese because a lot of developers are Chinese. My students like it very much. I implement mostly in my teaching, my studio. My studio is very high-level studio in the school because a lot of people compete want to come inside because we're sharing this platform with them, and also their feedback help us to update the new version because they are the users.
Yep.
They can challenge or test something failure on this platform. What's the problem there? So, but we open this to the users. If you like, also you're welcome to use them. I think that's what we're doing. A few cents. We have the third one is not open because it's not so developed. It's very based on the hardwares because the drones or the 2-eyes camera and also the some like different. It's based on collaboration with hardware. So that one will not open yet, but in the future we are looking forward to open part of it. So one team can not develop too many things, but we just sharing with us. Our motivation is not commercial motivation to earn money, because our vision is like to build a laboratory culture, a collaborative laboratory culture, and also the digital workshop culture, and based on this platform. And I think the most important, we should go to the next step, right? Yeah, if you want to open something, that you yourself must go ahead. Yes, you must develop something new. So that's what pushes us to do next year. So that's like year by year, we update the version. I think this way, what we built it's a kind of culture in Shanghai, and also we influence over China. A lot of universities actually follow us and make their own laboratories, and a lot of professors sharing their research with us in the different conference and different workshops. I think this is something we established over the past 15 years. I think that's why I think it's kind of open and sharing culture from China. I think it's important because we learn at the very beginning, we're learning from the world, learning a lot, and then we're sharing a lot. And then I think we growing together is based on this kind of sharing. I think it's most important to academic work. So originally maybe we just sign a lot of agreement, MOU with different universities, but nothing happened. But actually what we have done is actually it's real collaborate, real meeting with each other, and real sharing each other. I think this what's where we have done over the past few years.
Thank you. Thank you for the vision that I completely agree with.
Thank you. Thank you. Yeah.
Other questions from the audience? No? I think
Well,
impress you a lot. So I think we can close the session, I believe, or if you agree, or if there are any other last. No. You have comments, please.
Okay. No, it was very quick in reality, my question is because what I wanted to ask you more is because what is invisible in your lecture is that we have some very big knowledge, so creating the knowledge first. I like a lot the fact that you said we need to predict, so it's going to anticipate as much as possible, and this is requiring energy in a laboratory, while in the past or a long history has been demanded on an outdoor attempt. When you were speaking about the bricks in different positions, I was thinking to be in the construction site as an artist saying, can you rotate that? And workers at a certain point saying, no, I don't want to do anymore. Why? The machines is not making any progress. Your program is doing that. No? So anticipate and also why? So we have this big knowledge, and then the result that it seems happening magic. While I would like you to spend a few words on unpacking in the middle, from your experience, how your practice really changed during the year, and maybe fosters something at the very last years due to AI as well. So there's something in the process of you really making daily with your PhD, because you mentioned it, that there is a PhD due and everybody, all the PhD were quite maybe terrified about their life, to really have their daily habits, how the habits of working changed, and if there is something that there is still space for innovation or not, and where there are some parts that are resistant. For example, when there was the bridge, I was imagining the robot completely alone. Then I saw that at the very end, someone in a non-stop motion was intervening because maybe something changed. No, so unpacking what's happening in the middle, because for we as a research on design practice, I think is what we care most. No? So understanding what's happened in the laboratory. So,
Yeah, it's a very good philosophy question, actually. I think I changed a lot to myself. I'm a good designer when I was young to win a lot of competition, and my work was collected by New York MoMA, by M+ Hong Kong. I think a lot was collected. At the very beginning, I think people like my work is not because of computation. It's just because I'm a designer, right? And at the very beginning, I don't have robotics. So the real sequel, the first one is just by some rulers. We designed 6 rulers upside down, 12 rulers to control the rotation degree and design the structure connections, how to protect this rotation safely. I think all from the human-centric perspective as a good designer. I was trained as a designer with no computation, just like drawing, rendering everything by hand. That's my time, yes. But after that, I think I became a visiting scholar to MIT, and also we established a joint studio with MIT for 6 years, from 2003 to 2009. That changed a lot. I think also Philip Block from ETH got his PhD at that time, and after he came back, he also established a lot in the NCCR. I think I was changed, totally changed over the past 15 years. Right now, I'm quite friendly to introduce the machinic process, machinic creativity to my design process. Although I'm still the decision maker, but in my decision process, you can see the machine existence. I think I'm changed, totally changed. When I was a human designer, I'm good just in China, in Shanghai, and everyone knows, oh, this guy is a good designer. But after these 15 years, I think I have some global influence from a knowledge production perspective, because my team and me, we develop a lot of toolbox. Actually, the users are global users. I think from design an object to design a knowledge is a transformation. I think there's ways from the academia as a professor. I'm not 100% practical practitioner. I change to be academic practitioner. I think it makes some practice, but its praxis is based on research. I think that is something different. That's the human life, you know. I'm not Norman Foster, although I met him 2 days ago in my pavilion. Norman Foster is a professional architect. I think he is in his 80s, and he is a human-centric. His body, his intelligence is based on the materiality, the high-tech culture he built up. But age is age. It's a piece of paper is turning. The history is like turning. It's new history is coming. New future is coming. I think what's the problem today we consider is the climate change and the global issue, the planetary issue is a top question. It's not to a poetic or artistic designers right now. It's compared to the global issue, it's nothing, right? So if you can consider our future education and the future practice can influence the whole world, because these kind of like a global knowledge system, what's your contribution? It's not just from artistic perspective, but maybe from a knowledge perspective. Although we create different things, we make objects, still making things. But we should consider this kind of transformation To me, my interest actually from just a self-designed, human-centric to a human-machine collaborative process. I think that's I'm really changed. And decision-making process, for example, construction ball, as a human worker, they can make a decision during the process. Maybe it's not symmetrical. Maybe you can change as you like before the Renaissance time, there's something like that. But after Renaissance, after you have the rendering, people will follow in the drawings, right? But right now it's not drawings. We are following the modeling or the digital twins. And the process is not controlled by man, it's controlled by the machine, robotics. Robotics just follow the human. You become a co-pilot, it's like a partner of yours, it's robotics. So it's a kind of engaged to a hyperman or superman, right? Because robotics and human, you control them, you're at a partnership. Your partner is not a human body, partner is robotics. So the process is still in control, but it's difficult to say we want to rotate one piece of the brake. There's nothing happened like that. Maybe we should encounter different kind of difficulty and change a lot based on maybe the tolerance and some like accuracy issues. But I think the problem and the ways to define the problem is changed. That is, I should consider it's a real human-machine existence in the process right now. The time is coming. Right? So it's a very good question. Maybe some very theoretical question. Yes.
If I can, yeah, sure. Just a very short question.
Yeah.
First of all, thank you very much for your speech. And my question was about the dataset composition, because you told us about upgrading, the increasing of these datasets. But my question is more about, do you use specific criteria to make increase these datasets? Because I mean, we have a lot of generative tools, and some of them are very wide datasets, starting datasets. Others have very specific ones, and also the purpose changes between them. So what about your position in that?
That's a super academic question, actually. I think it could write a PhD essay, just follow this question. It's a very good question. What's the very recent discussion between my PhD and me last 2 weeks ago is on this topic, because after Renaissance time, we make drawings. Like the drawings is everything, like the plans, the sections, like the facade, everything. It's the drawings, actually, is the data. And if you make research on the city, we should understand the city from the drawings, by the sketches or by some like actual metrical drawings. That is before the modernism. And after modernism time, actually, all these kind of drawings are in certain kind of categories as criteria, proportions, materialities. You can define by different drawings, detailed drawings, for example, building technology by detailed drawings. That's a lot of regulations and criteria coming out. But go to the digital age, I think the most transformation is the 3D modeling. By the data, it's a model. It's not a plan. It's not a two-dimensional. It's a three-dimensional, right? The three-dimensional things is all based on the parameters, how you describe the building, and after this kind of modeling, we go to BIM. It's building information modeling, because we find the window is different to the wall. We should categorize them into different family. There's the window family and the wall family and door family. It's categorize them in the family. Right? This is BIM, and also to the city, we should not go to so accuracy. We can like simplify the model to some CIM, city information modeling, because it's more easily just the window and the wall. You separate them is enough, right? So there's a SIM and BIM. But after that, when we go to AI age, it's all changed. We define as a new concept. We want to write a paper on that. We name it a data-driven spatial information modeling. It's a DSIM. It's not the BIM and SIM. It's data-driven spatial information modeling. Why? Because the modeling process has changed. It's not by plan, by section to modeling a building. In my group, if we make research on Torino campus, we just make the drawings of flying around. From maybe we're shooting 20 images, and we can calculate and modeling your campus simultaneously by collage the images together and make a cloud system, a cloud system of points, cloud points to represent this 3D model, your campus. And we have another software can simultaneously transfer these cloud sets to mesh modeling. And we can also change this mesh modeling to some like parameters by some geometry system. And then the next step is we want to like separate what is window, what is wall, what is brick wall, what is concrete wall. So this all by AI. So the modeling process is a revolution. So I think the future is I explain a lot about the labeling, the label process, and the technology about images, how to calculate them, how to categorize them, how to modeling them. So that is the frontier of AI. If you want to really control AI as an expertise, you should understand what I'm talking. It's based on other softwares and other algorithms. But if you really want to make some design, it's not just by image, generate image, it's nothing. You should generate a model. You should generate different layers of models. Otherwise, you cannot make use of them, right? That is advanced technology by AI in purely architecture discipline in the near future. And also my team, right, two of my PhD students is very interested in this topic, your question. They're trying to, we define the name, but we need to write a paper to publish it. Okay. It's a data-driven spatial information model.
Okay.
Thank you. Thanks for your question.
I think thank you, Professor Yuan. Yes, I remember to all person here and online that Professor Yuan has another lecture today in Salone d'Onore at 6 p.m. So if you want to join, he will discuss more in detail about the digital future platform. So
yeah, and
another
Venice Valley Pavilion as well.
Exactly. So if you want to join, we are in Salone d'Onore. And for the PhD classes, the next one is 22nd of May. Okay, so we'll upload, I hope soon, about the location.
It will be an online meeting.
Okay, so no problem
We will
this
be
time.
online and you will have the link as soon as possible.
Okay, so thank you, Professor Yuan, again.
Thank you.